Okay, so this is part number 4. Is part number 4? It is, no?
It is 4.
All right. So limit as x approaches a constant, a number. We did that. And we checked also the square roots, cube roots, whatever. Limit as x approaches infinity plus or minus. We saw that yesterday. And some modulus. All right, so we're going to look at the tough cookies. I think after this, okay, because normally I know from our side, we had to do the sandwich theorem to prove something like this. Let's say sine of theta over theta. In other words, it will be between, there will be an area where I'm putting a question mark and also in other words, we're using the sandwich theorem. Okay. And then we're using the sector of a triangle because they might bring that one. So we will touch that. And then after also, yeah, I think you did epsilon and delta, the true definition of limit. Did you do that, epsilon and deltas?
No, I don't think so.
Where you saw something like this and something like that?
No, we haven't done that yet.
Okay, you won't even do it. Okay. And then thereafter, what was it? Yeah, I think after that, it was continuity. This one, 3 condition of continuity. But if you didn't do it, no problem. We'll move to the next one. So the sandwich theorem, you're going to have to check that one. All right? Yeah, if you're doing that. I think yesterday we covered this. We did this one, right? Yeah, we did.
Yeah.
And then we did this one as well. We did this one as well. We did this one. We were here. Limits as x approaches positive or negative infinity.
You just told me the rules, the shortcut rules.
Yes. Yeah. All right. Now here, what we know about x approaching infinity, you need to you go to the denominator, you find the x value with the highest degree, correct? Yeah. You must use it to divide every term in the numerator and denominator. But now, when we have something like this, we now have a problem because you'll be like, okay, I can see the x. Like in this one, you say, okay, I can see the x in the denominator. That is it's actually x. So I need to divide here by x. I don't have a problem there. I'm going to have to divide by x. But I'm having a problem here. How do I do this? Yeah, do I go beneath the set? Do I go inside that set? Or, but that wouldn't make sense because the set itself is one term. So you'd be like, okay, I need to divide the whole set by that. But you're like, oh my gosh, I don't even, it doesn't even make sense. That one. Can you say what I mean? It's like, oh my gosh, would it be 0 or what? Will that x cancel the x squared? What's going to happen? You want it in the normal sense. So now I'm going to tell you how we're going to do this one. Okay. I know the right way, but first I'm saying, let's try, let's say we rationalize. We're good, right? No, let's not even rationalize. Let me show you what we did yesterday. What we did yesterday, we needed to pull out x squared as a common vector, the x squared under the radical sign. So step by step, I'm going to write it here. So you have limit as x approaches infinity from the negative side or approaching the negative infinity. So under the square root, so I'm going to pull x, this is x squared And then this is still beneath the radical sign. So I'm going to have 1 plus. Remember, when you pull out the x squared, that means that x squared you are dividing by x squared. That's why I'm getting a 1. Before x, you're dividing it by x squared. So you're going to end up with 4 all over the x. You can verify it by multiplying it back. You'll see you get the same thing that is under that square root sign, the radical sign. You're going to get exactly the same thing. All right, and then we have minus 2x. And then everything is over the 2x. All right, so we've got a multiplication sign here in the radical, meaning the x squared is multiplying that. So you know when you've got in a radical, if you got a product, you can actually take out 1 on the outside, isn't it? You can split them. You know that, am I right?
Yeah. Yeah.
Okay. Limit as x approaches negative infinity. Now, one of the things I taught you yesterday, here's one of the key. I told you that the square root of a number squared, it is exactly the same as the absolute value of that number.
Yeah.
Right. So example, if I've got the square root in the bracket, let's put a 3, and then we square that. Actually, because it's squared, I can put plus or minus 3. You see, I can put plus or minus 3 there. So the answer will be the same. Yeah. It's still going to be 3. Can you see that?
Yeah.
So with the absolute value, it would have been the absolute value of plus or minus 3. You know, if the number is positive, you leave it as it is, because absolute value says make it positive if it's not. How? By multiplying by negative. That's how we had 2 rules, case 1 and case 2. So, all right. Anyway, let me not waste time, because I know you understand that. Good. All right. So I'm pulling out that x squared, but it's going to be under the radical on its own. So it's going to be the square root of x squared times the other one that remains. So it's also going to be the square root of the following. All right, the other portion that's left, which is 1 plus 4 all over the x, and then minus the 2x. There we go. And then we divide that. Can you see today I'm more relaxed? It's more pashashane.
Yeah.
Yeah, there we go. When I'm relaxed, I write nice and neat. Now, that square root of x squared, we know it should be either positive x or negative x. How do we decide? Because in the place of that, some people will write it as this. I would have myself, I love it. I would have write it as absolute value of x. Then I say, but we say we are approaching negative. That negative there is the one that tells me we are saying x is a negative. Therefore, that x must be multiplied by negative. So when I remove that square root of x squared, the x must be written as a negative. In other words, as case number 2. Are you happy with that one?
Yeah.
Okay, good. So now I have limit, and then x approaches, and then negative infinity. Then I now have negative x, and then under the radical sign, we've got that other part, which is 1 plus 4 over the x, and then minus the 2x. And then all over the 2x. all over the 2x. Now it's good. Now you've got nice, beautiful terms. Like for example, that term in a pink box and another term. It's 2 terms. Now, this term now, you can tell here, the x in the first term, the x with the highest degree is the yellow one. It's x to the 1. Because under the radical, that x is at the bottom. It's actually x to the -1. And if you were to take a square root, you will actually divide it. You'll divide it by 2. It will be x to the -1/2. Hence, this one is the biggest. Yeah, this one. I'm talking about at the top. We good, right?
Yeah.
Yeah. Or what we can do simply, we make the whole thing to become one huge term. You can pull out x as a common factor. That x there and also there by the 2. You can do that. But we don't have to. I don't have to. We'll do that maybe say next time. But you can see you can pull out as a common factor and zap. You can, and you get the same answer. So I'm going to write it as limit, and then x approaches negative infinite. And then I'm going to take what's right at the top there. I'm just going to bring it here because remember, this is numerator. We must divide it by the x that has the highest degree, this one at the bottom here. So that means if I can put division, you are going to divide here. Okay, let's just use this pink line. You're going to divide the numerator, each term individually, by the x. So I'm just going to put it as x here, and also here by x here. Yesterday, I was not showing. Today, I decided let me be a nice guy. And all over, you see, it's all over 2x, isn't it? But that 2x should be divided by the x as well. So now we can tell that will cancel that, and then that one will cancel that. Can you see now it's easy now that we have pulled out x outside the radical now. So no longer stress. And then that one will cancel that one. Now, if you want to, let's give the answer one time. The answer would be, now, let's check now. Remember, there's a minus here on the outside. So I'm going to keep it as minus. And then under the radical sign, remember you are substituting a negative infinity. So I'm going to have 1. Well, for that, the 4 over the x, it becomes a 0. You know that by now. Am I correct?
Yeah.
And then here you basically have -2. There's no place to substitute for the infinity. That's what you have now. And then all over, look at the bottom. At the bottom, you only have the 2. So that will be 2. Now, when I simplify here, I've got the square root of 1, which is 1, but times by the negative. It's going to be -1, -2, and then all over the 2. So our final answer would be -3 all over the 2. Can you see that?
Yeah.
All right. Now, I've got a question of which we're going to go after that. We are going to do it. The question is, why did I not rationalize? If we're to rationalize, was it going to work, yes or no? Well, let's give it a shot and